faster. Okay, that's one of the roles of the abdominals. So there we go. Now, the last thing we want to do here is we want to be able to analyze a spirometer trace. So a couple of things. First of all, any standard wave here is our tidal volume. So remember that tidal volume is the volume of air breathed in and out per breath. I'm simply going to write per breath. Now, of course, tidal volume can change. It can go up, it can go down, it can increase, it can decrease. Now, how does it do that? Well, tidal volume is effectively the utilization of this volume here. Now, this is our inspiratory reserve volume. That the graph goes up when we breathe in, down when we breathe out. So if we breathe in harder, we use up our IRV. So in other words, when we breathe in harder during exercise, IRV actually goes down. We use it up. It's a reserve volume. So we use it up. So tidal volume, because IRV is going down, tidal volume has to go up because it's taking it up. Similarly, this is our normal tidal volume, resting, and we use up our expiratory reserve. And of course, tidal volume, therefore, is greater because it's used up these reserve volumes in this case. Now, I know teachers are going to have a go at me because they're going to say, James, functional lung volume is not a term that's used on a specification. I agree, it isn't. But the point I want to make with this FLV, this functional lung volume, is simply say that your total lung volume or your utilizable lung volume is, in essence, tidal volume once it's used up inspiratory and expiratory reserve volume. So in other words, tidal volume can go to maximum level, your full capacity to breathe in and out as deeply as possible. And of course, that makes a greater possibility of diffusion. And alveolus. Just a reminder that alveoli do not empty. We always leave a small residue of air in the alveoli to ensure they don't become damaged and crushed. And that is, of course, our residual volume. So ensure you can use those terms, folks. In fact, here we go. This image shows a spirometer trace. I'm not going to draw the image out. Identify the lung volumes. In fact, I'll do that. Let me see if I've got my... Just bear with me a second while I get this. Let me see if I can not mess this up. I did want to... I've been logged out. Perfect. Anyway, so we've got here, A is our tidal volume, B is our expiratory reserve volume. You need to be able to identify those concepts. And then secondly here, to ask me explain the effect of exercise on lung volume A. And simply that is that the inspiratory reserve volume decreases during exercise. Why? Because tidal volume increases. So because I'm explaining it, I must say, yes, here IRV goes down. Why does it go down? Because increased tidal volume. And now you can bring that back to mechanics if you want. Our diaphragm and intercostal muscles are contracting harder. We've now got the sternocleidomastoid and pectorals drawing more air into the lung. In other words, we're using up our IRV and tidal volume increases as a result. Straight on, folks, because we're sort of towards the end of this canvas, so let's keep it going here. Aerobic and anaerobic exercise. So a couple of things I really want to stress other than what's on the page. Can I talk to you, please, about application? I can